Welcome and thank you for joining me for this lesson. In this video, we'll begin our introduction to asymptotes by exploring some special mathematical values. Our goal is to understand how to perform operations involving extremely large values and values that are extremely close to zero. Understanding how these values behave will help us explain how vertical asymptotes are formed and how horizontal asymptotes are determined in rational functions. Before we can understand asymptotes, we must first review concepts such as positive infinity, negative infinity, and values that approach zero. Recall that infinity is not a specific or a definite number. It is a symbol that is used to describe values that increase or decrease without limit. Positive infinity, written as plus infinity, describes positive numbers that become larger and larger without limit. Negative infinity describes negative numbers that become smaller and smaller without limit. We can visualize this by using the horizontal number line. So 0 is at the center of the number line, and we're going to say that positive infinity is represented by numbers on the far right side of the number line, and negative infinity is represented by numbers on the far left side of the number line. Next, let us consider numbers that are extremely close to 0, 0 minus, and 0 plus. The symbol 0 plus represents positive numbers that are very close to 0. The positive sign indicates that these values approach 0 from the right side of the number line, and it is not an exponent. Examples of numbers that approach 0 plus are 0, 1, 0, 0, 1, 0, 0, 0, 1, and so on. These numbers remain positive but become increasingly closer to 0. Similarly, the symbol 0 minus will represent negative numbers that are very close to 0. The negative signs indicates that these values approach 0 from the left side of the number line. And examples include numbers such as negative 0, 1, negative 0, 0, 1, negative 0, 0, 0, 1, and so on. These numbers remain negative but become increasingly closer to 0. Now, how do we perform operations involving these special values? Since infinity and values such as 0 plus and 0 minus are not specific numbers, we cannot always calculate the exact numerical result. Instead, we analyze the signs and estimate how the resulting values would behave. We'll examine the main mathematical operations such as addition, subtraction, multiplication, division, and powers, and determine how these values behave in each situation. We'll begin by exploring operations involving positive and negative infinity. Now, let's start with the addition. So, in this case, or in all these exercises or examples that I brought in, I would like you to try to guess the answer before we start discussing it. So use here a little bit of imagination, as always. So if we have an extremely large number added to an extremely large number, then we're going to say that we will obtain an extremely large number. So infinity plus infinity is equal to positive infinity. Now, if we have an extremely small number added to an extremely small number, then we're going to get an extremely small number. So negative infinity plus negative infinity will give a negative infinity. On the other hand, though, if we have an extremely large number and we're adding an extremely small number, we're going to say that this will be undefined, or in other words, we're going to write doesn't exist using the symbol DNE. Now, the reason why is because when comparing two infinities, like say if you open up the brackets here, then it will become infinity minus infinity. Now, if you're subtracting infinity from infinity, not knowing the size, the exact size of each infinity makes it impossible to see the difference between them. And that's the reason why we say that this is undefined. Now, next we'll look into subtraction, which is going to work in a similar way as addition. So if you have infinity minus infinity, again, we are running into the same situation as in here, then we're going to say this is undefined because we don't know how big an infinity we are subtracting from this infinity. If we have negative infinity minus negative infinity, this will turn into negative infinity plus infinity. So we run in a similar situation as in our previous example. So we're going to say again that it doesn't exist or it's undefined. Next, we have infinity minus negative infinity. So in this case, if we open up the brackets, that will end up being infinity plus infinity. So that, if you were to estimate, would be infinity. And negative infinity minus infinity will be negative infinity minus infinity. So we have two negative infinities together that will give negative infinity. Next, multiplication. Multiplying two very large numbers will give one very large number, so infinity. Multiplying a very large positive with a very large negative will give a very large number, and the sign will be negative since these two signs are opposite. Multiplying two very large negative numbers will give a very large number, and the sign of it will be positive because the two minus signs will multiply to give a positive. So we're going to continue with division, which is the more interesting kind of operation, in my opinion. So if you were to divide infinity by infinity, what do you think the answer would be? Well, whenever I ask this question in class, like the first reaction I get is that it has to be 1. Now, let's think about it again. And we're going to take as an example, let's say a numerical example. If we have number 6 and we were to divide it by 2, then you would say that the answer is 3. And we know this very well. And the reason why is because number 2 goes into number 6 3 times. Now I want you to think in a similar way in this division. What do you think? How many times can this infinity go into this other infinity? Are you able to visualize this, or are we able to estimate it? So as a matter of fact, because these two infinities are indefinite numbers, it is very difficult for us to compare them with one another. And this is why we say that in this case, this operation, so dividing infinity by infinity, doesn't exist. And in a similar way, we're going to think about the rest of the division. So the division of two infinities, no matter if they are positive or negative, or one positive and one negative, then the division doesn't work with infinity. Now let's move on to powers. If you have a very large number and you bring it to the power of a very large number, then we're going to get a very large number. So that would be infinity. If we have a very large number, bring it to the power of a negative infinity. If you apply the exponent laws and make that negative power in here into a positive, that will change to 1 over infinity to the power of infinity. So infinity to the power of infinity, that's infinity on its own. And if we divide number 1 by infinity, then we're going to get almost nothing, or 0. But we're going to say that it's going to be very close to 0 on the right-hand side because it's positive, so 0 plus. Now, in a similar way then, since we're at it, we're going to discuss negative infinity to the power of positive infinity. Negative infinity to the power of positive infinity, I want you to imagine, let's say, even negative 2, that is a definite number. If you bring it to the power of infinity, you wouldn't really know what the value of it will be, because when the base is negative, depending on whether the power is an odd or an even number, then the answer will be either positive or negative. And these are very extreme and very opposite, and they're actually opposite values. So bringing infinity to the power of a base with a negative sign makes no sense. So we're going to say that in this case, negative infinity to the power of infinity doesn't exist. In a similar way, negative infinity to the power of negative infinity will be, if we made an attempt to apply the exponent laws, will be 1 over an undefined number, which makes this entire term here undefined, or it doesn't exist. Now, in conclusion, when we evaluate expressions that involve infinities, So when can we evaluate them and when can we not? So is there a rule that we can remember or memorize? Well, operations that usually produce a definite result is when infinite quantities of the same size are added, infinite quantities are multiplied, provided that neither factor approaches zero, and that's a different concept that we are going to address in the calculus course. Or when many but not all powers that involve infinity can be evaluated. So this one here can be evaluated, this can be evaluated, but not all of them can. And for this, I wouldn't push anyone or myself to memorize it, just use your logical reasoning. Indeterminate forms are infinity minus infinity, plus minus infinity divided by plus minus infinity, negative infinity to the power of negative infinity, and negative infinity to the power of negative infinity. Now, if you wish, you can memorize the forms that are indeterminate, and then the rest are determinate. That's another way of memorizing the rules. So, an indeterminate form, though, and it's very important to add, doesn't mean that there is no answer. It means that the expression alone doesn't provide enough information, and we need to examine it more carefully to determine what happens. And I'm just trying to be here politically correct because we don't do this actually in advanced functions, but it is something that you address at the university level math. But as a matter of fact, even these expressions have a way to be evaluated. Now, operations with infinity and a constant number. Again, we're going to use our imagination here a little bit. So if we have infinity, a very large number, you add a positive, then you're going to get infinity. If we have infinity, a very large number, and you subtract a number, infinity will stay infinity. If we have negative infinity, we add a positive, it will stay negative infinity. And if we have a negative infinity, you add another negative number, it will become a heavier negative infinity, still negative infinity. Subtraction works in a similar way as addition. Infinity minus 3. Well, a very large number, subtract 3, still a very large number. Infinity minus negative 3. So that's infinity plus 3. Negative infinity minus 3 is negative infinity minus negative 3 is negative infinity plus 3 or negative infinity. So far we've been able to perform all the operations. Now, if you multiply an extremely large number by 3, that will give an extremely large number, infinity. Negative infinity times 3, that will give an extremely large number and a negative because of this negative sign. Infinity times negative 3, that would be a very large number, but now it will have a negative symbol because the signs are multiplied the exact same way as in numerical examples or expressions. And negative infinity times negative 3 will be a positive infinity. Now let's take a look at division. Division has always been a little bit tricky, but let's take a look at this. So if we have number 3, we want to divide it by infinity, then we're going to say that would be a very close to 0, but practically 0, theoretically 0 and a little bit more than that. So we're going to write 0 plus. Negative 3 over infinity, that would be again a 0, but a 0 minus, because negative. If you divide infinity by 3, it's still infinity. It is so large, it never ends. So dividing it by 3 doesn't do anything to it. And infinity divided by negative 3 will be negative infinity. So the sign will change. Now let's do powers. We have infinity to the power 3. That's infinity. Infinity to the power negative 3. That's 1 over infinity to the positive 3. That's 1 over infinity. We've done this in the previous exercise. So that is 0 plus. 3 to the power of infinity, that will be equal to infinity. So if you keep raising number 3 to a power, then it will increase to infinity. 3 to the power negative infinity will be 1 over 3 to infinity, which is 1 over infinity, and that will give 0 plus again. Now, when evaluating limits involving infinity and constant numbers, and by limits we mean estimating evaluating limits is used in the context of estimating these values. To evaluate limits, actually, since we're talking about this, in one word means to estimate. Okay? So to find the limit of something means to estimate something, not to find the exact value. Not necessarily. Sometimes the limit can give you the exact value. But evaluating limit is a general way of saying estimating something. So we're going to say 0 times infinity. These are indeterminate. Infinity to the power 0 is also indeterminate. 1 to infinity is indeterminate, and 0 to the power 0 is also indeterminate. We'll address all these very interesting terms or expressions at a separate video because they deserve special attention. Now, again, as we mentioned before, an indeterminate form doesn't mean that there is no answer. It means that the expression alone, again, doesn't provide enough information, so we need to examine it more carefully in order to determine what happens. Now, we're going to move on to operations with one-sided numbers, or as we call them, the right-handed and the left-handed numbers. So what are they? Remember that signs of numbers, we can extend the idea of 0 plus and 0 minus to actual numerical values that are different than 0. Recall that numbers that are on the left side of 0 are negative, and on the right side of 0, it's all positives. And that is because 0 is the most neutral number, right? The only neutral number, actually. Now, when we look at numbers other than 0 from the right and the left-hand side, we still use the symbols minus and plus to indicate the right and the left-hand side. However, the sign of the number doesn't have to change just because you approach it from the left or the right side of it. For example, if you look at number 3, when you approach number 3 from the right-hand side, you will have numbers that are slightly more than 3. As an example, I'm going to write in here 3.0001. That's a number on the right side of 3. And there are so many others, by the way, in case you are wondering about it. If you approach number 3 from the left-hand side, that means that these numbers will be smaller than 3 because they haven't reached number 3 yet. And as an example, I would bring in here number 2.999, and I can continue on forever. As you can see, this number is not negative. It's a positive number. That's because number 3 is positive. So this estimated value will have the same value as this base in here. Let's call it a base, or the number 3. The only difference that the negative sign will make now is that the number will be kind of eaten up a little bit, so smaller. So I'm trying again to emphasize the difference between 0 minus and 0 plus because it's a very common misconception and an easy mistake to make. Now let's take a look at negative numbers. So this is negative 3. If we are approaching negative 3 from the right-hand side, it means that, remember, this is negative 1, negative 2, so we are going slowly towards negative 3, not becoming negative 3. So these numbers, as an example of these numbers, we can take negative 2.999, and you can continue writing 9 as many times as you want. And 3 from the left-hand side means that, negative 3 from the left-hand side means that here we are, let's say at negative 4, and then we're getting closer and closer, negative 3.5, negative 3.1, negative 3.01. So the numbers in this case will be represented by numbers that look like this. And you can go as close as you want by adding more zeros to it. Again, as in 0 plus and 0 minus, plus and minus will tell us the side from which we approach the number. Now, why are we studying this? We will be encountering these numbers or operations with these numbers when calculating asymptotes in rational functions. And we're going to have to add, subtract, multiply, divide, or sometimes bring them to each other's power. So let's take a look at how they work. Now, I want you to imagine number slightly more than 5 added to number 5. So try to look at the number line as a start, since we're just learning this, until you get a full grasp of it. So 5 plus 5 will be 10. And because this 5 had a little bit more than 5, that will make 10 plus. Now, if you have 5 minus and you're adding just to number 5, exactly 5, it means that we have the number 4.999 and we're adding it to 5. So that will be about 9.999, which you can tell and you can see that is close to 10 but is on the left side of it. Now, in a similar way, we can discuss the subtraction. So if we have 5 plus minus 5, I'm just going to take some numerical examples. So we have 5.01 minus 5. So in this case, we're going to see that there is a difference of 0.1. And if we were to take a number even closer to 5, 5.00001, then you get 0.0001, or should we say 0 plus? Now, in a similar way, again, we have 5 minus minus 5. So 5 minus means we have 4.999. And you can add as many 9s as you wish. And then minus 5. Now, this time, the positive number is smaller, so we're going to get a number close to 0, but negative. So that's negative 0.0001, or 0 minus. Now, multiplication of one-sided numbers. So if we have 0 plus multiplied by 5, the multiplication will give us still 0, because multiplying by 0 gives 0, but it will be a 0 positive. Imagine multiplying 0.01 by 5. That's how close you can bring it in terms of explaining it. So if you have 0.000001, you multiply it by 5, you're going to get a very, very close to 0 number, 0.000005. Okay? Now, in a similar way, when we multiply 0 minus by 5, we're going to get 0.00, a negative, multiplied by 5 will give negative 0.000, how many zeros are here? 2, 4, 5, right? So this is going to be, again, a 0 minus. Let's move on. Now, next we have negative 5 times 0 plus. In a similar way, multiplication by 0 will give 0, but because the sign is negative, for negative 5, we'll get a 0 minus. And negative 5 times 0 minus, I'm going to write the example in here, negative 5 times negative 0.0001, that will give a positive 0. So we're going to say in this case that will give a 0 plus. Now, we're going to move on to division. We have 1 divided by 0 plus. So 1 divided by 0 plus, just to bring it closer to our imagination, 0.00000001. Use a calculator to find this, and you'll figure out that this is going to be quite a big number too. Okay, so it's going to be about 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be this very big number, but imagine that we can add as many zeros as we wish in here. So which means that we're going to practically get infinity. 3 divided by 0 minus, in a similar way, we have a constant number divided by negative 0.000001. So we're going to get a very large negative number. So we're going to say negative infinity. Negative 1 divided by 0 plus. Now, it doesn't really matter what these constants are, how big or how small they are. So the only way that they can affect the answer with is the signs. So negative 1 divided by 0 plus, again, is going to give a very large number, which will be negative in this case. And these two numbers will divide again to give a very, very, very large number. And because this is negative and this is a negative, so negative 3 divided by negative 0.000001, it will give a positive large number or positive infinity. Now, lastly, we're going to talk about the power. So infinity to the power of 3, that will be infinity. Infinity power negative 3, that would be equal to 1 over infinity power 3, that would be equal to 1 over infinity or 0 plus. 3 to the power of infinity will make infinity a very large number, and 3 to the power of negative infinity will be 1 over 3 to the power positive infinity, which is basically 1 divided by infinity or 0 plus. So this is all we wanted to discuss about the special numbers, and this is in preparation of discussing the horizontal and vertical asymptotes in rational functions, which I will explain in the next video. As always, thank you for learning with me, and bye for now.